So I am writing my trig ratios based on the numbers that I see in my triangle, sine, cosine, and tangent. And probably a good idea to put my little cheat code up here, SOHCAHTOA. In order to do this, we need to look at our reference angle here and use that to label our sides. Hypotenuse is always across from the 90. Opposite from the reference angle is opposite, and adjacent is right next to the reference angle. Then I just need to take those three numbers and put them into my ratios here. And this is where SOHCAHTOA helps us, because this tells us that sine is opposite over hypotenuse. So I'm going to look and see opposite hypotenuse, and I'm going to fill those numbers in the top and bottom of this ratio. Opposite was 9 over hypotenuse was 15. And that's all you have to do. That fraction does simplify, but you can just leave it like that. Cosine is adjacent over hypotenuse. So adjacent 12 over hypotenuse 15. And tangent is opposite over adjacent, opposite over adjacent. Opposite's 9, adjacent's 12. And that's it. If you haven't already, go ahead and look at that next problem and just do the exact same thing. All right, angles there. Labeling my sides, hypotenuse, opposite and adjacent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Can I get everybody, regardless of whether you're ignoring me or not, could I get you to check your answers to that first one against what I got on the screen? Some of you I know are working ahead, and that's just fine, but please check your answers. Make sure we're in agreement here. Again, as I was grading those tests, a lot of people did really well, but there were one or two types of problems that you're consistently getting wrong. So let's make sure that we're checking here. So I am going to warn you that on this sheet, I tried as best I could to cram as many of these problems on here as possible. So there's not a lot of room to write. You're going to have to write small. If you are not a small writer and you want to have a scratch piece of paper that you do your work on and staple it to this when you turn it in, that'll be fine. Again, this is not due on Friday. When will you be turning this in? Tuesday next week. You guys are awesome. Thank you for paying attention. All right, so what I'm going to do is for 3, 4, and 5, I'm going to do all three of them, but I'm going to go through and just write the equations for all three of them first. And then I will go back and solve all three of the equations all at one time. Okay, so we're going to practice this in 2 phases. First, writing the equations, and then go back and solving. And I'm going to need that SOHCAHTOA, so I'm going to squeeze it in up here. So when we start these problems, the first thing we're going to want to do is think about which sides we have available. We need to write an equation with 2 sides in it. In this case, we got an 8 and a 10 that we're going to end up using. I'm going to label these. The 10 is a hypotenuse and the 8 is an adjacent. The 2 sides that you're going to use are going to help you determine whether you're going to write a sine, cosine, or tangent. So adjacent and hypotenuse. So look through the SOHCAHTOA and think about which one has both adjacent and hypotenuse, which one has A and H in it. The answer is cosine. So for this first one, I need to write a cosine equation. The equations always look the same. Sine, cosine, or tangent. Then you've got parentheses, and the angle always goes in the parentheses. In this case, our angle is our variable theta. So I'll put that theta in there. If you don't like theta, you can use x. And then sides are going to go here, and we use our mnemonic SOHCAH TOA to help us find that. So cosine is adjacent on the top, hypotenuse on the bottom, so 8/10. I'm going to come back and solve that in a moment. Before I do, though, I'm going to go through and write equations for the other two. So number 4. Angles here. Let's label our two sides here. 13.5 is the hypotenuse. And opposite from my angle is the x. So this time I got opposite and hypotenuse, and I think through which one of my trig functions deals with opposite and hypotenuse. Sine has both of those in it. So we're going to make a sine equation this time. It's going to look a lot like that last one, but it'll have a sine instead. Recall that when we write these equations, the angle always goes in the parentheses. Our angle in this case is 46. And then in our fraction goes our side lengths. And the SOHCAH TOA helps me remember that its sine is opposite on top, hypotenuse on the bottom. So opposite on the top, which is x, hypotenuse on the bottom, that's 13.5. Again, I'm going to come back and solve that in just a minute. Before I do, though, let's go ahead and write an equation for this last one. Here, my angle is 72.3. And the two sides I'm going to be using are x and 14. So let's label them. Hypotenuse is here. That's neither of them. The 14 is opposites. The x is adjacent. Opposite and adjacent. I think we're using a tangent equation this time. Our angle always goes in the parentheses. And TOA tells it's opposite on the top and adjacent on the bottom. Opposite, adjacent. 14 on the top, x on the bottom. So we have our three equations. For those who are working on your own, are you writing out the equation? Some of you have developed some shortcuts. Those are not going to fly. I need you to at least write the equation. If you want to go straight from the equation to the answer, I'm okay with that. But you must write out the equation. Just answers will earn you 0 credit on this. Okay, let me talk about solving these. There's sort of two tools that we use to solve trig equations. One is cross multiplication or cross products, and the other one is inverses. Can anybody spot the one equation where we're going to need to use inverses of these three? There's one of these threes where we have to use inverses. Anthony, which one is it? 3, the cosine one. We have to use inverses. And what was it about number 3 that told you we were definitely going to need to use inverses here? So the thing we're solving for is the angle, or it's inside the parenthesis. Question? Or you were going to say the same thing? Awesome. Okay, so we got to get rid of this cosine, and then we'll have the theta, or x, if you decide to call it that by itself. So I'm going to rewrite this, leave myself a little space after the equal sign. Because the trick that we learned to cancel a cosine, to make it go away, is to do an inverse cosine. Inverse cosine and a cosine will cancel each other, the same way that multiplication and division cancel each other when you're solving, or the same way that addition and subtraction cancel each other. But just like anything else we do involving solving an equation, we have to do the same thing on both sides. Inverse cosine and cosine cancel. So all that we have left here is theta. We got it by itself. That's great. And I don't know what the inverse cosine of 8/10 is, but my calculator can find that for me. So from here, I'm going into the calculator. Make sure you're doing an inverse cosine. On most calculators, you have to tap the second button and then the cosine button to get that inverse. And it's 8/10. So I'm going to type 8 divided by 10 in my parentheses. Should be coming up with 36.9. For those who've already finished number 9, can you check and please make sure that you, or sorry, number 3 rather. If you finish number 3, can you check and make sure that you got 36.9? And again, we use that inverse whenever our angle is inside of the parentheses, or our variable is inside the parentheses, whenever our variable is an angle. Now, if the variable is over in the ratio, the fraction someplace, then we solve it the same way. These two are going to have the same method. Different from this, though. We're going to use cross products here. So to start off here, I'm going to turn this sine 46 into a fraction. I'm just going to put a 1 underneath the whole thing. So now it's a proportion, and we can solve proportions. We did a whole bunch of them back in chapter 3. We just cross multiply. I got 1 times x right here. 1 times x is x. And here I've got 13.5 times sine 46. These are my favorite ones because they're the fastest, because it's right away, as soon as I cross multiplied, I already had x by itself. X is by itself, so all I need to do is just take this and put it in a calculator and get an answer. So I'm typing in 13.5 sine 46 to get my final answer here. Comes out to about 9.7. So if you've already finished number 4, please check and make sure that you got 9.7. One more here, and then we'll move on. X is in the ratio, so I'll put that over 1. We'll cross multiply again. This one's going to take a little bit more steps. Because this time when I multiply by x, I'm going to have x times tangent of 72.3. This one, by the way, is the one that most people missed on the tests. This style of equation. And then 1 times 14 is 14. So you should end up with that equation. And in this equation, x is not by itself. So we cannot just plug it straight into the calculator. We need to do one more step of algebra to get that x by itself. How are we going to get rid of this tangent 72.3? Yes? So we use inverse tangent when our variables, if your variable's stuck inside of a sine, cosine, or tangent, that's when we use inverse tangent. We don't have that here because the x is not inside. So I like that you're thinking about inverse tangent, but not for this one. The x is multiplying by this tangent. What am I going to do when x is multiplying? We're going to divide on both sides by the thing that's multiplying by the x, which is tangent 72.3. And this looks a little messy, but it is going to cancel and get the x by itself. In this over here, I'm just going to type into the calculator. Except when I type this in, it's 14 divided by tangent 72.3. So one more step, punch some buttons on our calculator, get our final answer, and write it down. So 14 over divided by tangent 72.3 comes out to about 4.5. For those working ahead, please go back and check number 5 and make sure you got 4.5. We're going to switch gears away from trig here in just a moment. Does anybody have any questions over those 5 problems that we just did together? We will be doing some more example problems on Friday of this week. So for those of you who did not do as well on that trig test as you wanted to, you got a big opportunity coming up here. When we take our next test, it's going to have trig on it. And just like last semester, if you can score better the second time around, then I'll boost your grade. You guys know what happens if you score worse the second time around though, right? Both grades go in the grade book. The good one that you got the last time, and hypothetically speaking, because hopefully nobody does this, but if you do score lower, both grades go in the grade book, the lower one and the better one. I only make changes to grades if you show growth over time. If you're declining, then I need to put that lower grade in the grade book to show that you didn't really learn it that well. Okay. All right. Tuck that aside. I don't want to see anybody working on this for a little bit. I know some of you have made some great progress on it already, and that's awesome. You will have a little bit more time to work on it in Friday in class, but we need to move on and talk about some newer stuff now, because the other half of the test you're going to take in a week and a half is going to be on congruence. So let's get this going. Could you guys get your